Hello, everyone, and a very warm welcome to all of you to this webinar session with us and our business partner, GitLab, on the topic of GitLab versus Jenkins, cure your plugin overload. My name is Peter, and I will be your moderator for this session. I sincerely thank all of you for your participation in this webinar and really keenly looking forward to an engaging session. A little bit about the webinar today. In today's webinar, we are going to learn how GitLab can help you cure plugin overload. Also learn how GitLab offers a seamless workflow between SCM and CI and helps your team do better work at greater speeds, which results in reduced risk and greater stability in scaled projects. And also learn about how GitLab decreases toolchain downtime and eliminates risky integrations, which results in lower cost and increased efficiency. Let me also take a moment to introduce our speaker for the day, Itzik Gan-Baruch. Itzik is a technical marketing manager at GitLab with more than 20 years of experience working with enterprise software companies. Itzik has an engineering product and marketing background, expert in bridging the gap between business and technology. Itzik offers invaluable guidelines to GitLab customers by creating and delivering technical demos and workshops. Just a couple of last-minute house rules before we get started here. All of us will be muted during the presentation, and only Itzik will have the rights and access to present information. Itzik's presentation is going to last for roughly 40 minutes, and then he will open the floor for questions. Of course, if you do have some questions beforehand, please do not hesitate to use the questions tab on the right side panel on your screen. You may type in the questions and we will take a note of the same. And either we would answer the questions right then and there in the window, or we'll ask Itzik for an answer during the Q&A part in the end. Assuming you have good internet connectivity, this whole session should run smoothly without any impediments. However, if you're finding any difficulty during the session, kindly make a note of the same on the chat tab on the right side screen panel. We will instantly get in touch with you to help solve any potential issue without interrupting the webinar session. And finally, this webinar session will be recorded, and a copy of the recording will be passed on to each one of you via an email once the session is over by the GitLab team directly. Now, without any further delay, I hand over the floor to Itzik to run us all through his webinar session on GitLab versus Jenkins, cure your plugin overload. Itzik, over to you.
Thank you, and hi everyone, and thank you for joining to the webinar today. So the agenda for today is I will share with you some Jenkins pain points that we hear from Jenkins admins and users. And just a point, when I speak about Jenkins for today's webinar, I refer to the open source or free version of Jenkins. There are more versions like CloudBees or Jenkins X, which is not a part of today's session. Then I will share with you what is the main problem that GitLab solves and the GitLab advantages over Jenkins. And then I will summarize key differences between Jenkins and GitLab. And then we will follow up with the end-to-end GitLab DevOps live demo. And we will keep time for a Q&A. So, as a technical marketing manager, I had the chance to speak with a few Jenkins users and admin and hear from them why they decided to move to GitLab, and some of them didn't decide to move to GitLab. But I'm going to share with you common pain points that they told me. So everyone knows that Jenkins is free, but at the end, the total cost of ownership is very high of Jenkins, so it's not free because Jenkins has high maintenance. The architecture requires a large set of build environment, and it's a master and slave. So you need to manage a lot of machine. You need dedicated people to manage all of this complexity, and you need to monitor them. You need infrastructure. So at the end of the day, it's high maintenance and high total cost of ownership. When I spoke with people about upgrade, questions like, example, when was the last time that you upgraded the Jenkins? I heard people say 3 years ago or 2 years ago. And when I ask them why, they said it's not easy to upgrade. So if I upgrade, then there is a chance that some of the functionality will not work because of the plugin compatibility. So they are in a situation that they are scared to upgrade the versions. And they say if it works, they don't touch. And when I am talk about upgrade, I'm referring to the Jenkins server or to upgrade the plugin, because you upgrade plugin, you fix one problem, but then you will have other problems with other plugins. And the thing with Jenkins, because customers, I met people with hundreds of plugins, and when they have a problem, it's really difficult to pinpoint and understand where is the problem. It's hard to debug that. Another thing that I keep here is Jenkins is use Groovy as the language of the configuration. The problem with Groovy is easy to developer the script language and easy to developer to create complex logic that then is hard to maintain. And also it's hard to debug. There is no way to debug Groovy. So what they do, usually they print out some text, some messages into the console, and this is the way they find they try to debug and understand problems. And also, not everyone familiar with Java or Groovy, so it's difficult for many people to use Groovy. And another point is Jenkins is not just CI tool, it's an automation tool. And companies like it because it allows you to do everything. So any automation that they need to do, they use Jenkins. At the end of the day, Jenkins become very complex, hard to track, hard to debug or backup or to debug. Another big problem of Jenkins is the community plugins. So with Jenkins, you can do almost everything. But for everything that you want to do in a Jenkins, you need to rely on a community plugins that developed by a third party. It can be students or part-time people. And many people, we need to waste a lot of time to understand which plugin they need to use because there are many plugins. For each function, you can find 10 different plugins. So which one is the best for you to use? Sometimes plugin comes on a low quality or not stable. You run a pipeline and then one of the build machines stuck because of the plugin was not stable. Plugins has a list, each plugin has a list of compatibility. So each plugin depends on some other compatibilities. So for example, if you have a Java and you need to upgrade Java in order to install one plugin, then 3 other plugins will not work because they cannot be supported with the newer version of Java. And another problem that impact large enterprises is lack of visibility and control, because what happened in Jenkins, there are many teams. Each team has its own Jenkins master, and they have their tools, and then they download the plugins that they need for them. And then the organization, the CTO or a central IT team doesn't have a visibility, and there is no alignment to which plugins different teams are using. Another thing is that Jenkins was not designed for the Docker age. So again, you can find a plugin, and when I was looking for a plugin with the word Docker, I found something like 26 plugins with the name Docker. So which one to use? So there is no native support for Docker and container. And today, everyone knows that this is the standard of modern development: cloud, Kubernetes, and containers. And to do it with Jenkins, I keep here that it's possible, but it's not the best and the most convenient way to develop like that. More issues with Jenkins is it's not it's scalability issue, because it doesn't support clustering or failover. It introduces security issue, because when people download third-party plugins that you don't know who wrote these plugins, do you know if they are secured? Maybe they contain some vulnerabilities. So this is may bring a security issue. Also, for a large organization, there is an access and permission question. Who can access Jenkins? To which module he can access? And what is the level of permission you get in each module? Jenkins out of the box doesn't provide you this. And then again, you are the owner. You need to find a suitable plugin for that to solve this problem. And of course, there is lack of end-to-end auditing and compliance. And something which is very important for DevOps is visibility and collaboration. And with Jenkins, user even can't see others users commit. And users don't have any visibility to deploy the applications and the development lifecycle. Jenkins is only a CI tool. So CI is a great to use for DevOps as a beginner, but for mature DevOps, mature customers do CI/CD. And if you use Jenkins, it allows you the CI, and then you will need to take care for the CD by some custom deployment script. And again, you are on your own. There is no tool that do for you the job. You need to take care for everything. So this is another thing, or you need also to use a third party. And in this slide, I want to mention Jenkins X, because Jenkins X is a new version of Jenkins that come to address the CD. It provides CD capabilities and containers and Kubernetes integration, but it inherits the problems that Jenkins has, simply because Jenkins X is not a new code, is a patch of functionality on top of the Jenkins 2.0. So all of the problems like maintenance, plugin, upgrade, it inherits, and at least for now, if you install Jenkins X, you have all of those problems. Another challenge that Jenkins X introduces is it requires high system requirement. So gone of the days that if you have a problems with Jenkins, you have a machine in your team, you just install Jenkins and solve, make a workaround by creating another instance of Jenkins. With the Jenkins X, you will need to find very, very strong, you will not have it handy, such a machine to make workarounds. And Jenkins X is limited to Kubernetes cluster only for, at least for now. And it doesn't have UI. It uses only command line interface. And still it uses Groovy, which with all of these advantages of Groovy. But again, it's a better than Jenkins because it's a great step that they support Kubernetes and cloud native. So what GitLab solve? What is the problem that GitLab solve? This graphic demonstrates DevOps toolchain crisis and integration complexity. Companies have hundreds of companies have hundreds of tools. They're using different data models, which lead to lack of transparency. Different people work with different tools, which create silos team. But breaking down the silos was the whole point of DevOps in the first place. Moreover, dedicated people need to design, build, maintain this fragile toolchain. This toolchain complexity is the problem that GitLab solves. So this is the famous DevOps graphic that shows the typical DevOps lifecycle stages. GitLab provides a single platform for all of these stages. Here is another view of the graphic, which shows which capability GitLab has for each stage. All right, so now I want to a little bit expand about the advantages of GitLab. So first of all, GitLab is one tool for SCM, which is version control, CI, CD, issue tracking, security testing, and monitoring. You don't need the plugins and customization. You have one application, you get everything that you need for your DevOps. It's very easy to maintain and update GitLab. So for example, if you want to upgrade GitLab, you just need to replace one Docker image. And when you upgrade this Docker image, it upgrades for you not only the CI, but the CI CD, issue tracking, and all of the components by replacing one Docker image, and very easy without a risk. You don't need to scare. And GitLab release a new version every 20 seconds of each month. There is a new version that you can replace without a risk and get a lot of features that will help users to achieve the goal that they want when they're using, they are adopting DevOps. Another thing is that GitLab is optimized for containers. It has built-in container registry and Kubernetes integration, cluster monitoring, review app, all of the things that you need for developing cloud native application, you have it handy from the application. And developers has visibility to the entire development lifecycle. A little bit drill down in how GitLab works. It's a little bit different than Jenkins. So while in Jenkins you have the master and slave, here we have a GitLab Runner. The runner is the agent that actually runs the CI/CD. Runner written in Go for portability, so you can install it anywhere that support Go, and it has a native Docker support. And when I say Docker support, is not for the deployed application, but all of the build run inside a Docker. So if in a Jenkins you have the build slave, and then you need on that VM to make sure to install all of the build tools like Java and Ruby and all of the things that you need in order to run your job, you don't have to take care for that in GitLab, because in GitLab, when the job starts, it will download a Docker image, Docker container image and services, and run all of the job inside the container. When the job ends, it will revert back the machine. So in order to set up a Runner machine, you just need a machine to install on it on Runner, and Docker container you need to install, no more than that. And of course, it has built-in auto scaling. So I don't need to have a farm like in Jenkins with many slaves waiting for your jobs, because the build machine will be created on demand for you, and also it will save you a lot of money if you are using the cloud for those machines. So while the runner is running the CI/CD jobs, here is a look of how the GitLab CI/CD configuration looks like. So it uses a structured YAML format, easy to learn, and it prevents complexity because all of the logic is not exist in the YAML format. And of course, it's versioned. Also in Jenkins, it's versioned. You can edit it in your IDE, and it's part of the repository. On the right side, you can see an example of a script, YAML file actually. And all right. This slide shows the one permission model in GitLab. So you have 5 different levels of roles: guest, reporter, developer, maintainer, and owner. And in the help, the screen on the right side, you can see which role can access to which model. So when you define the user, you assign him a role, and then this role will be good to all of the dev components and the operations component. Only one single permissions model, where if you work with a Jenkins or with a toolchain, you will need a different permission model and access permission for each tool that you are using. And as we have seen, customers using hundreds of tools. This is what the analysts think about us. I took here 3 screenshots from the latest reports from Forrester and Gartner, and as you see, we are leaders, appears as the leaders in all of those reports. So just to summarize what we talked about Jenkins and GitLab, this is a table that summarizes the key differences between Jenkins and GitLab. So while Jenkins is a natively only continuous integration tool, GitLab is a complete DevOps platform, as you get complete CI/CD toolchain out of the box with SCM, security testing, issue tracking, monitoring, and thousands of features. Jenkins relies on integrating community plugins for basic capabilities, everything. So if you need the SCM, if you need issue tracking, roles and permissions, Docker, for everything you will need a plugin, while GitLab delivered as a single application. You have one installation, one interface, one conversation, one permission model. And the last one is the time where the 2 products started. So Jenkins, relatively old technology, was not designed for supporting cloud native development. What started on 2004, while GitLab started on 2014. Cloud and container were there. It was known, it is the standard in the future. It was built from ground up for DevOps and for modern development. And this is why it's more easy to developers to use it when they developing cloud native application. So there is no here feature to feature comparison, because to be honest, everything that you have in GitLab, you will find the equivalent plugin that Jenkins will do. And if tomorrow we will have another functionality, so in Jenkins someone will develop another plugin. So you can do the same in both tools, but the idea is how complex is to do it. If it's a tool that have this functionality with native support by design, or someone created a plugin with all of the risks that we just discussed. So this is the right things to do, not a feature by feature, because this can lead everything is as I said, it's the same. You cannot compare between the 2 tools feature to feature. Right, so the demo part. So right. Okay. So this is a GitLab project. You can see the project ID. I pushed a simple Java source code to the project, nothing special in this Java code, even though I don't have a CI/CD configuration file. In the project, I enabled the auto DevOps, and auto DevOps is a feature that based on pre-configured CI/CD templates that GitLab provide out of the box. So what it does, it will do for you all of the CI/CD automatically, and I will show you in the demo. Of course, if you will add here a CI/CD YAML with your configuration, it will not use the pre-configured templates. But if you don't have, if you just upload the source code and enable this auto DevOps, all of the DevOps will be done automatically. Also in this project, I configured the Kubernetes cluster. So this project is connected to cluster. And in GitLab, there is a native support for clustering, so for Kubernetes. So if you have any cluster on any cloud vendor, or even on your bare metal, you can just connect it and use it. Also, we have with the Google GKE, we have better integration, because you can, even from GitLab UI, you can automatically create cluster in Google, even if you are not familiar with cluster with Kubernetes, with a few fields in GitLab, simple fields like name, number of VMs, number of nodes, and it will create for you the cluster. All right, so on the left side, you see you have a menu with access to different tools because it's a single application. The first one is the project, the details. This is the page that we see. Activity, you can see all of the activities that happened to the team. For example, push, merge, even comment, issue, everything that your peers in the project have done, you will see it in the activity tab. It's very similar to Facebook notifications. Releases, security dashboard shows you all of the risk and the test result of all of the project. In one page, you can see all of the security risk and test result of that project. Dependency list, cycle analytics, insights. Another tab is the repository, access to your Git. You can see your repository, commits, branches, everything you can see from this UI. Again, issue tracking, which is part of the application, merge request, CI/CD pipelines. You click here, you will see all of the pipelines. Operations, all of your environment, your Kubernetes, your VMs, everything you can see here. Packages for container registry. GitLab has a built-in container registry. It has a wiki site, snippets, and project settings. So now what I'm going to show you is a simple DevOps development with GitLab, with all of the stages that I showed you in the presentation. So I will start with the issue tracking. I will create a new issue. I will give it a name. And I will assign it to myself. All right, now I go to planning and I will go to the issue boards. And this is a new project, so I don't have a list for my board. And here is a nice thing about GitLab that every time where you are new, it tells you what is the next step. So for example, here it tell me, welcome to your issue board. And they ask me, do you want to have your list or use the default list, which is to do and doing? So we will take this suggestion and we'll have to do and doing, and I will drag and drop the issue number 1 that I've just created. All right, so I created issue and now I can open the web IDE. So this is another feature in GitLab. It's very handy if you want to have quick changes. You don't need to use even your local IDE. You open the web IDE, it opens the repository. You can select the branch that you want to use, but now we have only the master. So I will go to the code and I will make a quick, very easy text change. Right, and I will click commit. I will stage the changes, and the web IDE shows me side by side the changes, the differences. Good. Click commit. I will add a commit message. And I will create a new branch. I will give it a name. I'm starting with number 1 to link it with issue number 1. So we will have transparency between issue and the branch and the merge request. And also when the merge will be accepted, issue number 1 will be closed automatically. So this is the merge request. Merge request is a main thing in GitLab because this is a place that we request to merge my feature branch into the master. This is the place that I need. We will have all of the discussions and all of the test results that will help me to get a decision if to merge or not to merge. I will mark it as a work in progress. Automatically, it fills it that it will close issue number 1. I will assign it to myself, and I will check this to keep the repository clean, and I will submit the merge request. If you notice, once I submitted the merge request, immediately it started a new pipeline. So I click, and here I can see a graphical representation of what's happening in the pipeline, and I see that the auto DevOps created it for me, and I have 5 stages: build, test, review, dust, and performance, and here are the jobs. If you want to drill down to see what happened, you can click here and see the build jobs. Currently, use Heroku build packs to build a Docker image and push it to the Docker registry. I see the build path, so I can go now to the container registry, and I see I have here 2 images. One is for the master, and one is for the branch that I've just created. So automatically, it creates for me a build, push to the registry. To go back to the pipeline. And now it's running a different tests like code quality, some scanning, license management, static security application testing, and some tests. And it created for me a review application. We are using a Kubernetes cluster. So this allows me to create a private instance of my change. So for each commit, for each branch, we have a personal, like think about personal staging for you with only for your change live application. Moreover, now you have dynamic application security testing and performance testing running on a live instance of your personal branch. This is a huge shift left, because right after, immediately, you push your change, you get a lot of feedback, not only on the static, your code, but also feedback on your live application. So I will go back now to the merge request to see the details that I got. So here I have a new button, View App, and this is the review app that it created for me. I can click on it, and this is the right really URL in the internet that we got with the change. I can now send this application, this URL to my colleagues like UX or PM, PMM, any people that I want to get feedback before I decide to merge it to the master. At the bottom of the merge request, I see some test result. The code quality test says there is no change to code quality, but the security detected vulnerabilities. I can click on the report, and I see here SAST and dust and container and dependency scanning. So this is huge functionality. So if I had to use Jenkins, for example, I needed to connect to at least 3 or 4 different tools with 3 or 4 different plugins, and then I needed to get 3 or 4 different reports. Now in one tool, I get immediately static application security testing, dynamic application security testing in one place with 0 configuration. Let's see what he gave me. He gave me all of those vulnerabilities. Click on one, I get a dialog with some details about severity. The source code, I can even click on the source code. It will open the Java code and even highlight for me the lines of code that led to this vulnerability. I can click here on the identifier, which tell me as a developer what was the problem and where is the solution, how to solve that. And because it's a single application connected to other tool, I will create now an issue with one click. It created for me automatically issue with all of the details that I need in order to fix it very fast. And now what I need to do is just to assign it to someone. I will just by default assign it to myself, and I will later on will fix the issue. I have a lot the needed information now to fix this issue. And dynamic application security testing also detected a few vulnerabilities. And here, for example, detected the cross-site scripting. And here it shows me instances of my live application. So let's click on one instance. This is the instance of my application that he found. Here, for example, there is a form. Whatever I type here and submit, he print it out. And this, for example, can lead to cross-site scripting. And the last test is the license management that shows me all of the licenses and all of the dependencies that I use in my dependency. Sometimes organization, if it's you use licenses that not comply with the organization policy, you can block it here and block the way that people will not be able to merge not allowed licenses into the master. Right. So okay. So here I can have all of the discussion. I can add my colleague and add the discussion. In this case, I say it looks good, and I will resolve the work in progress. And now I'm excited. I'm going to merge it to the master. I click here. And it merged it to the master. It closed the issue number 1, and a new pipeline started immediately. Now this pipeline run on the master branch. It's a little bit different because now it will deploy not to the review app, it will deploy directly into the production, because this is the deployment strategic that my default deployment strategy that I defined in the auto DevOps configuration. I want to show you that I create now a tag because I released the application. I can create a tag, give it a name, paste I paste some release note and create a tag. And now I have automatically have a release. With the release note, I have access to the source code, everything available to the developer. And again, we have also here all of the artifacts. Now it's a source code, but any artifact that I defined in my project, like test results, code quality report, or anything, or code coverage, we can have here as an artifact, and you can download it from the project. So this is the development lifecycle, and now I want to show you the operation side. So I go here to the operations in the environment, and here is all of my environments. Here I have my production environment, but if I add here VMs or other environments, this is the place that I would see it. This is the dashboard. So this little green box represents one Kubernetes pod. If I want to click on it, it will open for me the pod log. And this is another amazing, as the developer has very handy access to the pod log. And if I were using Jenkins or other tool, I needed to go to a different application. I needed a different permissions and spend maybe 5 minutes until I log into the application, navigate a few clicks until I get to this log. Now I have it very handy. More capabilities is that you can go to the production, click here and see all of the commits in the production. And of course, you can open and see the live application. Now, this is the live application that your users see. And now I want to show you another thing is as the environment variables. In this place, you can define any environment variable that you want, any secret credentials to the cloud or anything that you want to hide from the CI/CD pipeline. You add here, and only people with the right permissions will be able to see. In this case, I define a variable called production replicas, and I will define it the value 10. what will happen is now I will increase the number of pods in the Kubernetes cluster. So I'll go back to my environment. I will redeploy the application, and in the Kubernetes now, refresh a little bit. So adding this parameter increased my environment to 10 pods. Another thing that a developer can access easily and handy is the monitors. You can see the server monitors, and not only the monitors, you can see there is also correlation between code pushes and the metrics that you get in the monitor. So if, for example, at this time I click here, I can see the change that we just created. And of course, I can see the cluster metrics, and the developer has access to all of that from the single application. All what I did today is from unified UI, only from my browser. And another cool thing is that if you have a problems in production, the operation guy calls you, you can access to the container with the web terminal. And for example, you want to see the log. Now I am accessing to the container of my production application, again, from the single application. So I see I want to keep time for Q&A. So I think at this time, I will go back to the slides. And just I want to have a quick recap on what we've seen in the demo. So with the single application, single UI, we made the following actions. We created an issue and made code changes using the Web IDE. CI/CD pipeline started including build, test, deploy, dust, and performance test stages. Review app created for me, and Docker image pushed to the registry, to the built-in registry. We reviewed the test results and accepted the merge request. A new pipeline started and deployed the code to production. In the production, we access the production environment UI, the logs, the monitors, and everything from a single application. This is GitLab, easy for your developer to develop cloud native applications, and this is why developer like to use GitLab. Now I think we are on time for enough questions.
Yes, thank you so much, Itzik, for that presentation. We have a couple of questions that have been posted on the questions tab, and a few of them sent directly to us on the chat tab. Some users chatted with us directly. So the first question is, do you have a white paper stating your latency between endpoints within your software to edge implementation?
So if yeah, okay.
I can take that. You want to check? We don't have a specific white paper. If I understand your question correctly, it is regarding how long, like, does GitLab.com, for example, take to reach the Debian package managers. All our infrastructure is on GCP, so Google Cloud Platform, and we don't have any specific latency numbers, but since we're on the Google network, it's fairly low and it's not really noticeable. But this as well also is a case-by-case basis. If you're running GitLab.com on self-hosted, that's up to your network setup and your network stack.
Okay, great. The next question is, are all environments hosted by GitLab, or can you host on-prem or in your own cloud provider?
If you are talking about the environments that Itzik showed in the tab, it can be your own environment on-prem in the data center or in like Azure Azure Cloud or anything like that. It's just 2-3 lines that you put inside of your GitLab CI YAML file, where you specify this job will create environment and is located in X location. And then you can do deploys on that environment automatically.
All right. So the next question we have is, how are third-party tools supported? For example, Bitbucket, Artifactory, Jira, etc. Would it still be proper DevOps?
We do have support for we do have support for Jira and Artifactory. Bitbucket, as far as I know, we do not have support for CI, but at the end of the day, GitLab does provide everything that Bitbucket, Artifactory, and Jira provide. So we do have an issue tracker. Itzik showed that. Artifactory, we do have a package registry right inside of GitLab, where you can publish Maven builds and things like that. And of course, GitLab has the source code all there as well. So integration-wise, it's 2 out of 3 at this point.
Okay. The next question is, when it comes to a cost and maintenance question, what is the difference between having it cloud-based and having it on-prem?
That really depends on your setup. If it's something that you're handling 10,000 users on a GitLab instance, maintaining that yourself is a bit, it does involve some time. And the reason for that is there's a lot of moving parts on GitLab. It's a Ruby application, and then there's like maybe 10, 15 other microservices. So imagine that on top over your operational. We do handle all the upgrades and all that automatically. They're all scripted. So for you, it's just a matter of update, like telling GitLab you want to update. But at the end of the day, it's 10, 15 other systems that you have to handle. Now, GitLab.com, everything is handled for you. We have shared runners as well. So if you want to run your CI, we do provide all of that. And we are working on providing Windows shared runners and Mac shared runners in the future as well. But if you're on .com and you want to have more powerful runners, for example, like let's say your job consumes like 20 gigabytes of RAM, right? You can bring your own runner where you install it on your own data center or your own cloud provider, and you will contact GitLab.com and it will run the job for you.
Okay, we have another question from the same asker, which is, in the last 6 months, how many updates have you pushed and what were the size of these pushes?
Yeah, so we do releases every month. So every 22nd of the month, we do a release. So if you're talking about the last 6 months, it would be 6 updates overall. And it's a continuous list, right? It's around 5 to 10 features every month, or fixing some bugs and performance issues. I highly suggest you look at our blog post and the release tag, and that will have all the changelog. I can link that to you on the question.
Excellent. We have a couple more questions. The next one is, does GitLab support collaboration tools such as Slack, for example?
So it does, yes. For example, one integration we have with Slack is every time a pipeline fails, it can leave a comment into a Slack channel. And other things are, for example, if you open up a new issue or create a new merge request, you get a notification on Slack, or you can even create issues right inside of Slack. So if you're having a discussion on Slack and you say, oh, this needs to be an issue so we can track it, you can just type in a / command and it will create an issue automatically. So we do have those kind of integration.
Okay, great. Just notifying Daniel Prusinski, one of the question askers, that the link has been posted by Steve for one of the as one of the answers for the questions. And as an extended point on the third-party tool support, We have a comment and a question. The Oscar is saying that it sounds like a great thing, but also seems like a huge lock-in. What is GitLab's default response to this concern?
So the huge lock-in part, I do understand that concern, but at the end of the day, our goal at GitLab is to be the single DevOps tool for the single tool for the whole DevOps lifecycle. So I do understand the lock-in, but at the end of the day, right now, you don't have a lock-in, but then you just have an integration mess, right? What Itzik was saying earlier, like there's 10, 15 tools you have to integrate together, and if one tool changes something, your whole DevOps lifecycle is broken. And we don't provide the lock-in per se as cloud providers, right? We're working really hard to provide a multi-cloud architecture so you can deploy to AWS, GCP, and Azure at the same time.
Okay, we have one more question. It seems that a lot of development is targeting the build of Docker images. Do you extend the Docker registry handling with intuitive overview?
Yes, so GitLab does provide the Docker registry right inside of GitLab, and every job is authenticated to that Docker registry, so you can build image and push it into the registry or pull from that registry in a secure and private manner. And it does provide all as a normal Docker, like for example hub.docker.com. It's just like that, but on GitLab itself. And it's per project, so it's even like, for example, a private registry. So if you have a private project, you can host it privately there as well.
Excellent. Given your vision to be the DevOps tool, how do you handle data science models within your pipelines? More specifically, how do you model training, pruning, and deployment in an iterative way?
I'm not 200% familiar with the data science, but we do have some customers who are doing like simulations and like doing some. So we have our own data team who is doing this. I'll have to give you a link on how they are using GitLab CI for running data analytics and all that stuff. I will try and find the link now.
Okay, excellent. So I request the asker of that question to look out for the answer. Maybe if the link is found, then you could just paste it over there. They can look it up. Meanwhile, the next question is, can GitLab Runner work independently of GitLab or must work with GitLab? So
GitLab Runner must work with GitLab. It only knows how to talk to GitLab and does not know how to talk to any other SCM system. But we do have a GitHub integration. So your source code can stay inside of GitHub and we will run your CI jobs. But then for that to happen, you need to have a GitLab installation that will do all the magic there, and then GitLab will send the jobs to GitLab Runner. So GitLab Runner only talks to GitLab, but GitLab itself can talk to other repositories.
Got it. Just a quick note for the attention of Daniel Prusinski. The link for the data sciences question that you had asked has been posted by Steve. The next question, as an extension of the Docker registry, is do you plan to offer integration to external Docker registries?
So we are like, it depends on what kind of integration you are talking about. You can already log into external registries right inside of GitLab CI. So it's just a matter of doing a Docker login, and then you have the credentials, right? So you can save the credentials inside of a secret inside of GitLab CI, and you do a login automatically. And like we do have like customers who are using, for example, Quay.io, that are using Quay.io and using GitLab CI to build images, pull images, and push images to Quay.io.
Okay, I now have the final question, which is GitLab free like Jenkins?
So GitLab do offer a community edition, and it's free and open source for you to download. Of course, we do have a paid tier, and some features are behind those tiers, but the basic stuff like GitLab CI, running jobs, doing deployments, Kubernetes integrations, most of what Itzik showed are all in the free version, in the community edition.
Okay, we have one more question that has come in. Do you have CI/CD pipeline examples following trunk-based development, such as branch code release strategy, leveraging also Git merge request and review application features?
Yes, so we do have a specific document. We call it the GitLab Flow, and I will give you a link for that on how we suggest you do trunk-based development, having different environments and having different releases, versions, and things like that. So I will send that, and I will send also another link, other examples. For example, how to deploy a PHP application, how to deploy to Heroku, and things like that.
Awesome. Excellent. That looks like all of the questions were in and all of them were answered. But if you do have more questions, then feel free to write back to WeConnect team so we could pass it on to Itzik, Steve, and the GitLab team for them to be able to get back in touch with you. Like I mentioned before, the webinar session is entirely recorded, and the recorded piece will be sent to each one of the registrants via an email by the GitLab team, so you could access the presentation again whenever you would like to. And I sincerely thank Itzik and Steve, our guest speakers for the day from GitLab, for having given a wonderful presentation and having engaged with the audience with all the questions and answers. This one webinar session is one of the final ones in the Code Cafe series for the year 2019. And we have more interesting stuff coming up in Code Cafe Hub in the coming days and weeks, and also a lot more interesting stuff in 2020 as well, including virtual summits, webinars, and content syndication campaigns. Once again, thank you so much for both the speakers and all of the attendees and the registrants for having shown interest in this webinar. We look forward to having you on more of these in the coming days and weeks. Thank you and have a nice evening. Bye.